I believe that many of you were taught about metric unit conversions through a teacher named King Hector. And King Hector had his own mnemonic. Went something like, there are different versions, but King Hector doesn't, maybe like mind or gag, depending upon whether you're dealing with meters or liters or grams, drinking chocolate milk. There are a number of limiting things about King Hector's approach. The first is that it doesn't cover all metric prefixes. The second is that it uses metric prefixes that hardly anyone uses, like hector and hecto and deca and deci. Third thing is it doesn't work for English conversions. It doesn't work for English to metric conversions, metric to English conversions, and it doesn't work for square and cubic terms. Okay, so let's take a look at this method of unit conversion that I'm presenting to you. Some people call it dimensional analysis, although dimensional analysis involves a lot more than what I'll be talking about. Some people call it factor label. There is a third name that you can use, and you'll know that name in just a moment. There are just two things that you really need to be able to do with this method. Let's look at the first thing. You need to be able to solve this problem. 7 times 1. What's that, you say? 7. Okay, I'll make it a little bit harder. 7 times 1 times 1. See if I can trick you. 7, you say. You're still right. Let's make this even harder. 7 times 1 times 1 times 4 over 4 equals, and you still say 7. Dimensional analysis, if you wish to call it that, really just involves a problem like that, in the sense that we will be multiplying by numbers which I say are, quote, just like 1. Just like 1 in the sense that the top, the numerator, will be the same as the bottom, the denominator. Not the same number, but the same value. Now, the second part that you need to know in order to do dimensional analysis is that you have to have a facility with assassinating units, hence the ninjas. So if you wish, you may call this the ninja conversion system. Alright, so let's do our first example, 0.0078 kilograms to milligrams. We'll try that a long way, another long way, and then a short way. Pretty soon I think you'll only do it the short way. So we start off with what we're given, which is 0.0078 kilograms. And then what's going to happen is that we're going to go from what we're given to the root unit, and then from the root unit to what we want. So that's going to take two terms. We want to assassinate units. So if I have a kilogram on the top, I'm going to need a kilogram on the bottom. The root unit, kilogram. So the root unit is going to be gram. And then from grams, assassinate units, grams on top over there, we're going to milligram over here. Now, all we have to do is think in terms of tug of war. Who's the little guy? Who's the big guy? Here, grams is the little guy, and we have 10 to the third grams is a kilogram. And here, little guy, big guy, again, the little guy is milligram, milli is 1,000th, and therefore we have 1,000 little guys equals a big guy. Let's just check this. Assassinate units here, assassinate units here. Check that it's a bunch of the little guys, not 10 to the third kilograms. 1,000 big guys equals a big guy. A bunch of the little guys equals a big guy. A bunch of the little guys equals a big guy over here. So our answer is 0.0078. Powers of 10, we're multiplying two powers of 10, so we're going to add the exponents times 10 to the 6, and let's not forget the units, milligrams. Supposing if I ask you to state the final answer in scientific notation. Well, 0.0078. Remember, in scientific notation, the first part of scientific notation has all the significant digits. So we have two significant digits over here, times. Now, going from 0.0078 to 7.8, we made it larger by 3 decimal places, by 3 powers of 10. So we better make this smaller by 3 powers of 10, and that's going to be times 10 to the third milligrams. And that's our answer. Let's try this another long way. So we've got 0.0078 again, kilograms, and times, again, kilograms on top, we want to assassinate, so kilograms on bottom. We'll go to the root unit. From the root unit, we'll go to what we wish. And then what you could have done is to say that perhaps the definition you're more used to, instead of thinking of tug of war, a bunch of little guys equals a big guy, you could say a little guy is some small fraction of a big guy. A little guy is a milligram is going to be equal to 10 to the actually over here, I guess since you've memorized it this way, I would still put a kilogram is 10 to the third grams, but you may have memorized that a milligram therefore is 10 to the minus 3 grams. Doesn't matter any way that we do it. And again, we have 0.0078. And here we have 10 to the third over 10 to the minus third. Dividing, we subtract exponents. The 3 minus a minus 3 is going to be 6. So again, that's going to be 10 to the 6. And when we use scientific notation, once again, that will be 7.8 times 10 to the third milligrams. Okay, now the short way. Let's start again. 0.0078 kilograms. And the next step, really, we're just going to go kilograms, because we need to assassinate the units, over to milligrams directly. This you can really do in your mind's eye, but just to review the tug of war that we did before, the root unit here is going to be gram, and that's 10 to the 0, and we don't even need to throw that in. Kilogram is going to be 10 to the third. Milligram is 10 to the minus 3. And there is a factor of 10 to the 6 from milligrams to kilograms. I always like to think of a whole bunch of little guys equals a big guy. So we have 10 to the 6 milligrams equals a kilogram. And there it is. So we go directly 0.0078 times 10 to the 6 milligrams. And once again, you can convert that to scientific notation. Let's look at a second example. Once again, we'll do it a long way and then the short way. So we're going from nanometers to gigameters. We'll begin with what we're given, 0.0080 nanometers. And nanometer. Meter is going to be the root unit, so we'll go from what we're given to the root unit, and then we'll go from the root unit to what we want. Okay, so a nanometer is 10 to the minus 9th meters. Therefore, I like to think in terms of positive powers of 10. You don't have to. 10 to the 9th little guys, a whole bunch of little guys equals a big guy. And over here, a gigameter is, let's see, mega is 10 to the 6th, giga is 10 to the 9th. A gigameter is 10 to the 9th meters. So we've got 0.0080. And then what do we have? It's 1 over 10 to the 9th times 10 to the 9th is going to be 10 to the 18th. This will be gigameters. 1 over 10 to the 18th is going to be equal to 10 to the minus 18 gigameters. And now let's write it in terms of scientific notation. We have two significant digits. These two are not significant because they're zeros. Number less than 1 immediately to the right of the decimal place. And the 8 here is significant. This is significant, so we have 8.0. Going from 0.008 to 8.0, we made it larger by 3 decimal places. Therefore, we should make this smaller by 3 decimal places, and we get times 10 to the minus 21 gigameters. And that will be the answer. Okay, now let's try this the short way. We have 0.0080 nanometers. And let's go directly from nanometer to gigameter. This time, let's try it in our mind's eye. Nano is 10 to the minus 9. Giga is 10 to the 9. So from minus 9 to plus 9, we're going to have 18 powers of 10, a factor of 10 to the 18th. Who's the little guy? It's nano. Therefore, this will be 10 to the 18th. Writing this out again, we're going to have 0.0080 times 1 over 10 to the 18th is going to be 10 to the minus 18th gigameters. And once again, we can convert that to scientific notation.